So, one more today's class will discuss velocity and acceleration diagram for slider mechanism. This is the given data. We have crank length OB 30 mm. In connecting rod is length of connecting rod is available 120 mm. The crank position is 160 degree and the crank speed is available, which is 300 rpm in clockwise direction. Okay, and we have to find out the velocity of piston C, then angular velocity of connecting rod, acceleration of piston C, and angular acceleration of connecting rod. Okay, so first we should know the value of angular velocity of that crank. So speed is available 300 rpm. So you can calculate angular speed by considering 2 pi upon 60. So speed of that crank will be 31.41 radian per second. Now crank rotates with uniform speed, so acceleration will be 0. So we can determine the velocity of the crank OB by taking R into omega, that is length of that crank or radius of crank into angular speed of crank. So to take that value of 0.03 meter and angular velocity 31.41, we get velocity of crank 0.9424 meter per second. So first we discuss how to plot that mechanism. So just draw one horizontal line of stroke. Then take the crank OB 30 mm at an angle of 60 degree. Then take B as a center and cut the distance of 120 mm on that line of stroke. Okay, we have to take B as a center and we need to cut the distance on line of stroke. We'll get location of slider C. So just mark that C point and connect CB line. Okay. After this, we have to first plot a velocity diagram. Now, how one can plot velocity diagram? Again, you have to consider length of that particular link, angular velocity, linear velocity, and the orientation. So for crank OB, the length is 30 mm. Angular speed is available 31.41 radian per second. So you can calculate velocity 0.9425 meter per second by taking R into omega. Then next we have connecting rod length 120 mm. Now we have to measure the velocity of that connecting rod length by drawing velocity polygon. Okay. And last class we have discussed about the orientation. So velocity component is tangential to motion. Just need to draw perpendicular line to OB in downward side, perpendicular line to BC in again in this direction, and line of stroke for slider C in horizontal direction. Okay. So first we will locate that point O. Okay. On point O, we will draw one line that is perpendicular to OB, VOB, that is velocity of B with respect to O. What is that magnitude? 0.9425 meter per second. So our scale is 1:0.1. So you can take this part up to 4.7 centimeter. Okay. After plotting this, we have to draw one perpendicular for this BC line. So again, mark a second perpendicular to BC line, then one line of stroke for point C, which is in horizontal direction. Okay. This horizontal line of stroke and perpendicular line will form one point of intersection where we have to locate point C. This is the orientation of C. So just connect OC and CB line. So this will be velocity of CB. This will be velocity of C with respect to O. So in this way, we can calculate velocity of BC or CB, we can say, by taking scale. So this distance is around 2.4 centimeter. So 2.4 into scale 0.2, it is 0.48 meter per second. Okay. And this velocity of C with respect to 0.2, that is 4.6 into 0.2 centimeter. So 4.6 into 0.2 scale, it will be 0.92 meter per second. Okay. So once we have the velocity for that point BC, then you can take V is equal to R omega, omega will be V by R. So just by taking this part of velocity upon 12 dimensions, we have angular velocity of connecting rod CB, that is 4 radian per second. Okay, so this is the velocity of piston, and this will be the angular velocity of link BC. Then next part, we have to draw acceleration diagram. Okay. Now again, we have discussed that we have normal acceleration and tangential acceleration. So normal acceleration is always parallel to link towards the origin. Tangential acceleration is perpendicular to link. Now to plot that part, again we have to take link, then we can calculate normal acceleration value, then we can define the direction. Okay. So what we have normal component of acceleration from for crank OB will be R into omega square. That is 31.416 square, that will be omega R is 0.03. So that normal acceleration value will be 29.6 meter per second square. Tangential acceleration will be zero because crank rotates with uniform speed. That's why there is no any tangential acceleration. The next part, what we have, the normal acceleration for BC, that is r into omega square. Okay, so again we can take that part 4 square into 0.12. It will be 192 meter per second square. So 4 radian per second will be the acceleration for connecting rod, and this dimensions will be 0.12. And next part is acceleration for slider C, that we need to measure. So by considering this OC dash and to scale, we can define that part. Okay, so first we will look at point O. Now look at the rotation. Crank rotates with uniform speed. Now we will draw B parallel to this OB line, parallel to given link, but in opposite direction. So B dash will be in downward direction. So what is the value of normal acceleration? 29.6. So we can take scale 1 as to 4. 1 centimeter is equal to 4 meter per second square. So this line will be up around uh, 7.4 centimeter. Okay. Then next, after plotting this, we have to look at second line. Okay, that will be normal acceleration for BC. It is 1.92, so it is around 1 as to 2 means it is around 0.5 centimeter. Okay, just draw line parallel to this BC. Again, draw one perpendicular for this line. So this is the perpendicular tangential acceleration for BC. There is one more part. This acceleration for slider C, which will be in horizontal direction. So intersection of this line and perpendicular line will define the orientation of C dash, that is the orientation of slider C. So just connect C dash and B dash and C dash and O dash. So we can determine the orientation of C. So we have to find out acceleration of slider C. So just measure the distance, multiply by scale. Okay. So if you multiply by this distance into scale, this value is around 2.7 centimeter, 2.7 into 4. This will be around 10.8 meter per second square. And acceleration of that BC will be tangential component of acceleration upon actual length. So what is tangential component? This x dash and c dash, that will be the tangential component. That value is around 6.5 centimeters. So take that part, 6.5 into 4 is around 26 meter per second square. Okay. So by taking that 26 meter per second square upon actual length 0.12, we have acceleration of CB 216.67 radian per second. Second square. Okay, so in this way we can determine acceleration component for connecting rod, angular acceleration for sliders. So this is the overall procedure how to plot velocity and acceleration diagram for slider. Okay. Stop.